happening here?
We're looking straight down. The bedding is almost up and down. So we're on the north side of the anticline that Sugarloaf Mountain is the top of. Now let's see if I can get some loose pieces here. I've never found much in the way of fossils here. There are supposed to be fossils in this rock. Here I'm shooting a gun. Yeah, there's a shooting range near here. But don't worry, they're not shooting students. Or at least if they have, they did it so well that nobody ever found out about it.
Don't worry, these people are Republicans. They only shoot commies.
But that's defined as Democrats.
No, I define them as the other totalitarian group.
No, I'm still not finding any fossils here. But
we never found a fossil here.
No, I know we never have, but eventually I hope.
You told us a story one time about a rock you took to some fossil people, but it turned out it was something else.
Oh yeah, that was in Kentucky.
That was an interesting story.
I'll go over it again. I mapped. I was responsible for mapping one topographic, making a topographic quadrangle map into a geologic quadrangle map, and the geology there is a lot duller than around here because it's what's called layer cake geology. But the Kentucky River has carved a gorge across the bluegrass because the land has risen about 1,000 feet or so, and the river has just kept on cutting down. But in times before the river had cut down as far as it has, it used to have big meanders over the surface. Then when the land rose, the river cut down. But those meanders are still there in the upland, and they have gravel in them. Question, how old is that gravel? When was the last time the river ever flowed in those abandoned meanders? And they've got some good guesses, but no good numbers on them. So I thought I found a tooth in the gravel. A fossil. We can date it. I showed it around the office, and this is the U.S. Geological Survey office. It's filled with geologists. So these are not random people off the street. And they were all very happy that I had found it. And they said, you know, you ought to send it to one of the survey paleontologists, and he'll be able to tell you what it is, and maybe it'll be something that can put a date on the gravel. And so I sent it in, and I got back an answer a couple of weeks later, saying that what I had found was a cartridge, and that they didn't do ballistics. I would feel worse about that, except for the fact that I had shown it around the office and everyone else. You have to realize this was not in good shape. This was all messed up. What we do have here, because I have gone wandering around in the fields up here at times, and you can find nice big quartz pebbles, you know, maybe fairly big, rounded. Obviously they're stream rocks. Wait a minute, this is up on top of the hills. What is going on finding stream rocks up here on the hill? It turns out that this is we're quite close to the Potomac River here. You've probably seen the signs for C&O Canal. And this was the course of the Potomac River, maybe 1 million years ago, maybe 100,000 years ago. Again, don't have a date on it, but the old river gravels are still here. That is a river rock, and it was deposited here when the Potomac was actually up at this level before it wore away down to its present level. Now, one of the things you quickly learn if you do geology is that what you're looking at around you now, the landscape that you're seeing, is something temporary. Everything changes. You know, this is where the river was so long ago, and there was no valley over there. This was the valley. And this is just maybe 100,000 years ago, or 1 million. Again, no dates on it. If you can find a horse tooth or something, an old horse tooth in the gravel up there, That's the sort of thing we'd be looking for. Now, geologically, of course, that is just the other day. I'm talking about 100,000 or a million years there. If you worked on it, probably the best bet would be if you could dig up some of the gravel and some of the sand on the river top and see if you could find some pollen in it, because that's very widespread and pollen can be used, it is fossil and you can date things. I don't know that anybody has done it, but again, that would be something if you were looking for a master's thesis. It would be very good for a master's thesis to date the terrace river gravels here. Now, I say 100,000 years ago. This rock is more like 450 million years old. It is early Paleozoic, Ordovician to be exact. And now I can say it with some certainty because this stuff does have fossils in it. And we can compare the fossils here to the fossils on the other side of the Blue Ridge to say which beds of limestone are equivalent to which other beds of limestone on the other side. Fossils are extremely useful. There are some that aren't, by the way. There's one called Lingula. It's very characteristic of brackish water. There are no, so far as we know, there are no freshwater brachiopods, and never have been, as far as we know. And Lingula is found today in mud flats in, say, the Philippines, on this continent. But it's fairly uncommon. The same genus Lingula can be found in rocks of this age. They give it a different species name, and you can probably tell them apart, but they're very closely related. Lingula is not a fossil you look for to date rocks. It's nearly useless because it has way, 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 way too big a range. You want one that lived for maybe 5 million years. And in the context of, well, we'll be looking at billion-year-old rocks by the end of the day. In the context of 1 billion years, 5 million is nothing. 1 billion is 1,000 million. And then when I say 100,000 years, oh my God, that's just the other day. Okay, it's 11:45. Let's go get some ice cream.
You said pollen, fossilized pollen. How do
Yes.
you recognize that in a rock?
Under a microscope.
Oh,
You don't find it in the field. You bring back
Okay.
you bring back likely looking sediments and then spend a lot of time looking through the microscope. Well, that's how I found my minerals. I found rock that actually I never told that story. I just want to do that before we go. I had read in a mineralogy book that was written in the early 1940s about a rare mineral that was found in the Great Smoky Mountains under an overhanging cliff in large masses, a manganese aluminum sulfate called upjohnite. I was going to school in Kentucky at the time, which is a morning's drive. And I said, I wonder if it's still there. Went off one weekend, drove down, hiked up. It's a mile, I think it's a several miles hike to 1 mile above sea level. Absolutely beautiful hike, one of the most popular hikes in the Smokies. Anyway, the mineral was still there, found large masses of it. I also found some little greenish, that looked like greenish stains in the middle of the rock where I broke it open. The algae growing in the middle of the rock. I better look at that. I took some back, looked at it under the microscope, and they were crystals. Little bright yellow-green, gemmy, sharp crystals, a fraction of a millimeter in size. Of what? This is not one of the 30 minerals that you picked up in the lab.
There's a beautiful
Oh,
raptor
what
there.
are they?
Birds.
Sorry.
Black vulture. They were vultures, but the question is which one. We have two. Anyway, at the time I was at the University of Kentucky, and they had some of that $1 million equipment, and so I put it in the X-ray machine and got an X-ray pattern on it, which was fairly standard, and matched it up to a pattern, that's in the literature, and it was a mineral called Slavicite. No, you never heard of that either. Neither has anyone else. There were only, at the time, there were only 6 known locations in the world, none of them in North America. Wait a minute, I go up there and I poke around for 15 minutes and I find something that's never been seen on the continent before? When did somebody ever check this place out? It turned out the last time somebody had checked it out was late 1800s, and nobody had looked at it since then.
No x-rays then either.
They didn't have x-rays then either, and the mineral was undescribed
Oh my god.
then. So I said, you know, I think just for fun, I think I'll come back down here and I'm going to try to find all the minerals that are at this particular place and get a paper out of it and publish it, you know, because that would be of interest. So that's exactly what I did. Went back with a backpack and took back about 20 pounds of rock and spent the next 20 years. Well, not continually, you understand. I did have other things to do, but I took it, and what I did was break it down into little pieces, an inch, half an inch in size, and look at it under the microscope for hours on end. And I came up with about 20 or 30 different things. What they were, some of them you could identify easily. Some of them were obvious. Gypsum. The gypsum was in good. These are too. You can't measure things like hardness and such. These are too small. These are microscopic crystals. But I'm familiar with crystal shapes, and these were gypsum. They were gypsum crystals, and quite a few of the others I could identify. Some of them I could put a tentative identification on. There was one in particular that was in little pink plates, very flat plates, that had a good cleavage that you could see under the microscope.
Yeah.
It's far away.
That was across the platy shape. And that actually matched an iron sulfate. And this place is full of sulfates and full of iron, so you know that's a good bet. Well, maybe Quinstead type. And eventually, I was working later in Oak Ridge, Tennessee. Ran into a fellow that worked at Oak Ridge National Lab. He was interested in minerals, and he had an electron microscope, which will give you a quick and dirty chemical analysis. And I made a deal with him, you know, if you can analyze and identify some of the stuff that I've collected, you can be a co-author of the paper. And that was a good deal. And so I took my iron sulfate. That was one of the ones he did. There's no iron in it. I guess it wasn't Quinstead type. Matches it physically, but no. Instead, it's a cerium sulfate. Cerium sulfate? There ain't no such mineral. It's a new mineral.
Oh my god.
Brand new. No, it's not a good analysis. And I found that out because then I know I have a new mineral, and I called up an old classmate of mine from MIT. He was a grad student when I was there as an undergrad, and he and I did not, you know, we didn't associate with each other. So I called him out and I said, hey Don, I know you don't remember me, but I was a classmate at MIT back in the 60s. I have a brand new mineral. It's a rare earth sulfate, and I don't have the equipment available to do a proper description of it. Would you be interested in, because one of the things he had been doing for the last 40 years had been working describing new minerals. He was an old hand at this stuff. He laughed when I said it though. There's the backstory to that. One of his graduate students had found a new rare earth sulfate, a praseodymium oxysulfate in Texas that he had identified and called Texasite. I remembered it because I had tried to buy some when it first came out, and he was out. And Don laughed when I mentioned that I had a rare earth sulfate, because it turned out his student was a fraud. What he had was praseodymium oxysulfate, 99.99% pure, straight out of the chemistry supply jar.
Oh my god.
And they were able to demonstrate this. It turns out it did have one impurity in it, very tiny impurity, parts per million gold. That doesn't belong there. It turns out when they purify these things, they 99.9% pure. Chemistry people like to have it pure. Geologists don't give a damn. But the chemistry people want it pure, and they do it in gold crucibles. So it was a fingerprint saying that this was indeed a fake. It was indeed a praseodymium oxysulfate, but it was not a mineral. And the guy ended up losing his degree. And now I come and I have a sulfate. I told him, Don, I know why you're laughing. I know the whole story. I will guarantee this one myself. I collected it myself, but you can make your own judgment when I send it to you. It's not 99% pure, and it's with a whole bunch of other stuff, and it's clearly natural, but you make the decision. So I sent it to him, and he called back a couple of weeks later and said, yes, indeed, you have a new mineral, but it isn't a cerium and other rare earth sulfate. You're wrong there. It's a sulfate oxalate. It has an oxalic acid component to it too. And it turns out that an electron microscope does not detect light elements like carbon and oxygen. So the oxalate didn't show up in the electron microscope analysis. And that was the big reason why he was convinced that it was real, because I didn't know. My method did not detect it. And then I followed up later by sending him the two other minerals as well, which also turned out to be rare earth oxalate sulfates. It's raining.
Yeah, it's about to get it.
I'm gonna drown. Anyway,
They're refilling the old Potomac.
let's go get some ice cream.